you may remember the difference between them, okay? So you have studied before that solid particles or solid state particles has a definite shape. Sorry. Particles uh, has definite shape and definite volume, okay? So the interaction between particles in the solid state are very, very big, okay? Particles are highly connected with each other. There is no intermolecular distance between particles in solid state, okay? And liquid state particles are a little bit free to move. They have a slight degree of freedom that they can move a little bit freely from the solid state. Okay, so they have they can have the shape of the container. They can take any kind of shape. Okay, but they still have some kind of definite volume. Okay, but in gaseous state, particles has neither a definite shape, neither nor definite volume. So the particles are free to move in all direction. Okay, and this is this you can conclude something about the behavior of matter in the gas state, that there is no kind of connection between particles. Okay, particles can move at a very, very high speed. The speed of particles in gas state sometimes reach to the 0.500 meter per second. Okay, so you can imagine, like, if you have something that can move with about 500 meter per second, how much faster this is will be very, very big. Okay, just in 2 seconds it can take to 1 kilometer. So the amount of the movement of particles in a gas state is a very, very free. Okay, particles are allowed to be free to move in all directions. So you might already know some of this information about from your previous studies, but today we are just going to add a small details about the kind of interaction happening between matter in the solid and liquid state as a molecular case. Okay, we are dealing about molecules. Okay, so what is the difference? Like, what is the difference between the solid, liquid, and gas state? Okay, so as you may see here, this is the shape of the molecule. Okay, you can see here there is some kind of connection. There is something that hold two things together. We call this the connection as a molecule. For example, imagine this as a this as a hydrogen, the water molecule. You can find here, this is the oxygen, the big here is oxygen, and the two sides are hydrogen atoms. So this is a basic representation to what we mean by molecules. So molecules are connection between different kind of atoms. Okay, so when you have two atoms, as I told you from the beginning, you you can form a molecule. Okay, so as I told you, the shape of the particles in the solid state is rigid, fixed, fixed shape, fixed volume. Okay, this is only about solid state. Okay, but in the liquid state, as I told you, the shape of the particles will be a little bit different from the solid state. So we will have particles are not so rigid to each other, so they are have a little bit degree of freedom to move in all directions. They have no fixed shape. They have no fixed they have fixed volume. But when you are going to when you turn it to the gas state, something different will happen. Okay, particles also, in addition to have no fixed shape, they will have no fixed volume. Okay, so um, particles in the solid state, and this is something we are going to study in details when we study the gas law and something like that. You will find that the particles in the liquid state, particles can't be pressed. Okay, you can't compress the particles in the liquid state. So the particles here in the liquid state are incompressible. Okay, to imagine that try to compress a water, you are not going to have, you have no way to compress water. Okay, but you can compress gas can be compressed. Okay, but water or liquid in general can't be compressed, and this is a slight difference between liquid and gas state. Okay, so you can hear it say the representation of solid, liquid, and gas. Okay, who can tell me now about the difference between the connection of particles in the solid and liquid state and gas state? Raise your hand if you can tell me now the difference between them. Like you can look at the picture now. Okay, look at this slide and just try to detect the difference between solid, liquid, and gas state. Here, if you can just, if you may find the difference in this picture between the kind of coordination, the kind of organization of particles in the three states, and just tell me the difference. Okay, Yahya?
Mister, I
Yahya?
have two questions before I answer.
Okay, ask.
The first question we took before that water can be hardly compressed, not compressed at all.
Yeah, water, the solid water, any liquid. Yahya, this rule is applied to any kind of liquid. Okay, liquid are incompressible. All the liquids are incompressible. You can't compress any liquid. Okay, so this is a basic rule for all different kind of liquids. Okay, but you may have just tried to mix between the difference between different kind of water, because we have solid state water as ice, and this something you can compress it. You have a gas state as a water vapor. So you just try to differentiate. But when we talk about liquid as a liquid water, liquid water can't be compressed. Okay, just keep this in your mind. Okay. Okay. The second question. Yes.
I can't see the picture you mean for me to answer.
Okay, I'm going just now to show you the. Can you see the picture now, Yahya?
No, I see File Explorer with some PDF files.
Oh, there is all of you can see the picture. I think this is a presentation. This is not a PDF. Okay.
No, I'm seeing only File Explorer, nothing else.
File Explorer.
Yes, with many files like this.
But you can't see any pictures.
No, I can't see.
Okay. So, okay, thank you. So I'm just going to explain this for you. Okay, I don't know what happened to the file. بي دي اف وبرزنتيشن مش معروض عندهم انه فايل انترنت اكسبلور. ده طبيعي ولا؟ وحد بيقول لي ان هو Okay. Yahya, can you see this picture now?
Yes.
Okay, can you answer this? What is the difference between?
Solid has strong electrostatic forces between them, so they are not freely moving.
Yeah.
Moving freely. Waters, the electrostatic force between them is weaker than solids.
Yeah.
So they can partially move, and gases has very weak electrostatic forces, so they can freely move everywhere.
Means as you are going to increase move from solid to gas, the intermolecular distance between particles is going to increase too. So the intermolecular distance between particles is going to increase. Very good. Okay. So thank you, Yahya. So here, as Yahya said, okay, you can find here the connection between particles in the solid state, okay, is very, very, very big, okay? Particles are highly connected with each other, okay? You can find this here in the distance between particles. Distance between this particle, it's very, very small. Here, particles are highly connected with each other, okay? Moving to the liquid state, the distance between the particles will increase, okay? So particles will be a little bit free to move, okay? You can find here, instead of just finding all the particles are in the same way, you can find here some particles are close to each other, other are not so close to each other, okay? In the gas state, the condition will be more and more free, okay? So particles has a more degree of freedom. They can move faster and faster than solid and liquid state. So now what we can just understand from this kind of figure about the different kind of representation of solid, liquid, gas state is moving from solid to gas, the degree of freedom of particles will increase, and particles will be more have a high degree of freedom to move in all directions, okay? Moving from gas to solid, the degree of freedom of particles to move will decrease, okay? So this is the basic difference between solid and liquid and gas, okay? We are going now to add some details to this. The general view about the difference between solid, liquid, and gas are very, very clear now, but we are going just now to try to differentiate between them based on a new kind of standards, okay? So here you can find here, okay, this is NaCl, okay? And if you remember NaCl from you're studying for chemistry, you remember this is the salt, the table salt you are using every day for your food. So NaCl is a crystal, okay? And you can find here, if we are going just to represent the Na as the blue one and Cl as a red one. So you can find here, you can find the connection here. For every blue one, you have a red one, and so every blue one is surrounded by a red one. Every blue one is surrounded by one blue, and every red is surrounded by blue also. So there's some kind of connection between, for every one of red you will find blue, and for every red blue you'll find a red. So this kind of representation, we call this representation as crystal. Crystal means some kind of representation of the of solid state, okay? So this is the representation of solid state. So this is the representation of solid state. So you can find here every particle is surrounded by, every Na molecule is surrounded by Cl, every Na is surrounded by Cl. And this is kind of representation for the particles in the solid state, okay? You can find every one is surrounded by another one. We call this as a crystalline representation for the matter. Crystalline means you are going to represent the matter in the form of crystal, okay? And crystal means particle will take some kind of organization, okay? So there will be some kind of organization for your matter into every atom will take some kind of position, and surrounded with different kind of other atoms, and this representation will be the same all over the molecule. Okay, so if I have millions or billions of molecules of NaCl, it will take the same kind of representation. You have Na and Cl, and for every NaCl, it has another, for Na, it has a Cl atom. So there is some kind of, organization of particles in the solid and liquid state. Okay, Hashim?
Yes,
Hashim?
Mr. Yeah, Mr. My question is that how can you represent it? I mean, where are the connections?
The connection here, if you remember, Hashim, that there is some kind of ionic bond between particles in NaCl. So the connection between particles in the solid state is based on this kind of bond. Okay, so the ionic bond is try to connect the two parts of the bond, Na and Cl, by this kind of representation. So, and you understand that you can't
Yeah,
connect any atom with each other to form a molecule without forming a bond. Okay, even
okay.
ionic bond, covalent bond, coordination bond. So you have different hydrogen bond. So you have different kind of bonds. Okay, and the function of bonds is to connect different kind of atoms with each other to form a molecule. So without bond, you can't form a molecule. Okay, so that here for NaCl, this is a crystalline structure. Okay, and this is a solid
Yeah,
state.
Mr. So
Yes,
how can we define this crystalline structure?
we can define this crystalline structure as we have an organized and ordered representation for the matter, the solid state, as we are going to state now. So for every NaU, it is surrounded by a Cl atom. Okay, and this kind of representation is fixed all over the matter. Okay, all over the number of NaCl molecules you have inside your matter. Okay, so you may kind of, for example, this is a very small particle. Okay, sorry, this is a very small molecule. So can you imagine, Hashim, if you have billions of this kind of molecule, how much kind of representation, how much kind of organization will be um, all over the
Yeah,
molecule?
how we will represent that
It
billions
will,
of.
here I'm just trying to represent something, a very small part of this molecule, but to represent something like that atoms can't be seen by our eyes. Okay, so you have two atoms and you try to connect them with each other. So just something like, if you are going to take a slightly amount of matter in your hand, it has a millions of, sometimes billions of molecules. So you can imagine how much it's already represented by this kind of shape. Okay, so this is shape, the matter. So Hashim, it will take randomly. Okay, the
Okay.
matter, it will take in a normal way. No one will tell the matter to take this kind of shape. It,
Okay. Yeah.
because this is a covalent, this is, sorry, a ionic bond connected the matter, the particle of Na with the particle of Cl. So when you are just going to you know the connect the Na particles or the Na atoms with the Cl atoms, it will take this kind of shape. Okay, regardless of what kind of anything they are going to do, but they are going to behaving in this way, because this
In
is,
the state of solid only.
yeah, in the state of solid. Yeah, we are talking right now about the solid state. We are not talking, later we are going to
Yeah.
talk about the liquid and gas state. Okay,
Okay.
so we understand the difference between them now.
Yes.
Okay, and how we can represent them. Okay, so thank you, Hashim. So the second question we are going to or the second kind of matter we are going to talk about is liquid state. So we started to talk about solid state, and we started to talk about solid state, and now we are going to talk about liquid state. So liquid state, I'm not going to just call them as a disordered matter. I'm just going to call them as a semi-ordered, okay? Because it's in between case between, or in between state between the solid, which is highly organized, and the gas state, which is non-organized at all, okay? So that the particles in the liquid state are, I can describe them fairly as semi-ordered. Semi-ordered means they have a slight degree of order, but they are not as much order as the particles in the solid state, okay? So this is a representation of particles in solid state, sorry, in liquid state. So we can find some particles are a little bit ordered, and other particles are move freely. For this, for this sake, we are describing them as a semi-ordered, semi-ordered because they have some kind of a little bit of order for the molecules, but they still have a high degree of freedom to move freely in all directions, okay? Because there is the intermolecular distance between particles are bigger than, okay? So this is a representation of matter in liquid state, okay? But don't forget something, okay? Particles in the solid state are highly, particles in the solid state are highly connected with each other, okay? Particles in the solid state are highly connected with each other. Particles in the liquid state are less connected with each other, and particles in the gas state are have a high degree of freedom to move, okay? So this is the difference between the representation of matter, so between solid and liquid, okay? Okay, so now we are talking about the particles in the liquid state. So they are highly moving particles. They can move in all directions. They have no rules to just govern the movement of particles. They can, as I told you, particles, the amount of speed that particles can move with in the gas state are very, very, very big, okay? Yeah, like about 500 meter per second, 500 meter per second. And you can imagine how much big this number is, okay? So this number is very, very big. And this number just showing you how much freedom the particles in the gas state are, okay? So they have a high degree of freedom to move in all directions. And this is a reason that gas state particles can take any kind of shape, can take any kind of volume. There is no kind of connection between particles. The intermolecular distance between particles in the gas state are very, very big. There is no intermolecular force between particles because particles will not connect with each other, and the kinetic energy of the particles in the gas state are higher than the kinetic energy in the part of particles in the gas in the liquid state and solid state. And there is another difference between solid and liquid state is about density of particles, okay? So the gas state are less dense than other states like solid state and solid and liquid state. In fact, the solid state particles has a high amount of density, okay? Comparing them with that other two states. and moving from liquid to gas, okay, the density of the particles, the density will decrease slightly between the different kind of matters, okay? So this is just to understand the difference between particles based on everything, okay? The energy between them, but I'm going to ask you a question now, and you know, I want you to participate with me in this. To if you can just try to answer this question. Can you imagine? Can you predict the amount, or can you predict which kind of state, what kind of movement for particles in the solid state? What kind, if I have particles in solid state, so do you think particles are moving or they can't move? Okay, so and if they can move, what kind of movement can you predict? Okay, so if you can answer this question, raise your hand. If you can answer this question, raise your hand. Shahd?
They can vibrate in their place.
Very good, Shahd. Thank you. So particles in the solid state, particles,
They move in their
particles in solid state are vibrating. So means they are vibrating in the same position, okay? They are not going to move because they have no way to move. They have no energy to move. They need to decrease the distance between them to move freely, but they can vibrate in the same position, okay? So to understand the idea of the particles, of the movement of particles in solid state, just try to, I'm going just to go back for a moment just to show you how these particles can move, okay? So we have here this part, this is a solid particle. Just try to imagine this particle is moving up here or moving down, okay? This is a vibration that we were talking about. The vibration is something you are even going to move up or move down. So you are vibrating around the same position. You are not going to move right or left, or you are going to change or displace your original position, but just you are going to move in the same position, all over the same position. We call this kind of movement vibration. So vibration is the position around the same position, movement around the same position. So you are not going to change your position, but you are going just to move around, okay? Just up or down, okay? And we call this vibration. And you can imagine that every solid state like can move, but by vibrating, okay? So the vibration is a kind of movement that particles can behave in the solid state matter, okay? But in liquid state or gas state, particles can move, okay? Particles, for example, because the particles in the solid state are not connected with each other in the liquid state as it is in the solid state. So particles are free to a little bit free to move in directions, okay? So this is a big difference between the solid and liquid and gas state. The amount or the way, the ability that particles can move in solid state, we call it vibration, okay? And this is a specific or some very, very specific phenomena for matter in the solid state. But when talk about the particles in the solid and liquid state, matter are a little bit free to move, okay? Because they have, as I told you, they have a little bit, you know, higher intermolecular distance, so they can move more free than solid state, okay? So we are going now to talk about two connected phenomena with the concept of solid and liquid and gas state. So diffusion is some phenomena related to the particles in the gas state. So what do we mean by diffusion?